Alright, this is question 5 on the 2011 Form B. So I'm again assuming you've read the question, so we're just going to jump right in. Use the data in the table to approximate his acceleration at time 5. Acceleration is the derivative of velocity. So time 5 is between 0 and 10. So for part A, I'm simply going to find v of 10 minus v of 0 over 10 minus 0. So I'm going to find the average rate of change between the points around it. So that's going to give me v of 10 is 2.3 minus v of 0 is 2 over 10. So that's going to be 0.3 over 10, which is going to be 0.03, I guess. Indicate units of measure, and that was meters per second squared. Alright, part B is done. It's getting really late, by the way, so I'm going to try and rush through this. Maybe I've already said that. Using correct units, tell me what this means. So when we integrate, we're adding them all up, but what are we adding up? We're adding up the velocity, but all of it turned positive. In other words, we're taking the negative parts and we're flipping around. So we're not finding net area, we're finding total area. And for this, the area under velocity curve is position. So what this means is the integral from 0 to 60, absolute value of v of t is the total distance traveled in meters Ben rides his unicycle during the first 60 seconds. During the, let's see here, first minute. Something like that. Part C. No, not done yet. Part B. Using left Riemann sums, let's find the answer to that question. Okay. So I'm going to add up the velocities. So that means I'm going to use the left side to make a rectangle. So the left side is 2. The width of the interval is 10. Plus the left side is 2.3. And the width of the interval is 30. And the left side is 2.5. And the amount is 20. So 2, 2.3, 2.5. Okay, I think that's it. I guess they want me to find the actual answer. So what's that going to be? 20 plus, let's see here, 2 times 2.5 is 5, times 10 is 50, plus 30 times 2 is 60, so what are we going to have here? 30 times 2.3, 9, 6, 9, 0, what did I do here? Oh, 1 decimal place. So 69. Alright. For some reason I'm not trusting myself, but that's because it's late. So I got 139 meters. Alright, part C. from 40 to 60, must there be a time when Ben's velocity is 2 meters per second? Justify your answer. So, Ben's velocity. So we're focusing on velocity. So I'm going to do the mean value theorem. I'm going to find v of 60 minus v of 40 over 60 minus 40. So it's going to be 4.6 minus 2.5 over 60. Alright, hold on a second. It's 2 meters per second. Alright, I'm rethinking my approach here. Ben's velocity is 2. This is velocity. 2.5 to 4.9. So I'm actually using the wrong data. I should be looking at B. B is my position graph. So they want to know if the slope somewhere between 40 to 60, if that same slope has to show up, and the slope they're asking about is a slope of 2. So my guess is that if we find the slope on B, it's going to equal 2, and so our answer will be yes. Alright, so I use velocity basically, and I should have been using position. Alright, so let's try this again. B of 60 minus B of 40 is going to be 49 minus 9 over 20. So that's 40 over 20, which is 2. So we're going to say yes, because the mean value theorem. I'm going to do more than that, but that's really at the heart of what I want to say. And so maybe we need to put something else in here. And we could talk about, because the function's continuous and differentiable, then the average rate of change has to equal the instant, and since the average is 2, then somewhere there has to be an instant of 2. That's what we need to say. It's approaching midnight. I'm tired. I'm not writing it down. Okay? Everybody hopefully understands what we just did here. Since the average is 2, somewhere there has to be a location where it's 2. Part D. So now you got a light at one end of the track, and Ben rides, so his time, so at the time t, the distance L is given by this equation. And it just wants to know, how is L changing at 40? The distance is L, so all they're really asking you to do is find, dl dt. So I need to take the derivative of this equation with respect to time. Okay. So I guess we'll just do it. So it looks like I got some chain rules and some implicit differentiation. So I get 2 L of t's to the first power times dl dt equals 0 plus 2 b of t to the first power times db dt. Alright. At what rate is the distance between Ben and the light changing at time 40? So I'm going to plug in 40 for this and see what I find. So 2 times L of 40, so I got to figure out what to do with that, times dl dt, which is what I'm solving for, 2 bt, which is, now again we're plugging in 40, so 2 times b of 40 times db dt at 40. Well, dB dt is velocity, and velocity at 40 is 2.5. Okay, so the only thing left to figure out is this L of 40 thing. And this is how L is defined. And so I guess I need to plug in 40 and solve for L. So B of 40 is 9. 9 squared is 81. So it looks like I get a statement that says, and again, sorry for the mess here, it says L of t squared equals, and I've got 144 plus, what do we say, B of 40 is 9. So 9 squared is 81. So LT squared equals, let's see, what's that going to be? 225. 5, 8 plus 4, 8, 9, 10, 11, 12. Carry the 1. 225. Okay. So that's what goes here. 225. Okay. Which is going to be 450. dl dt equals B of 40 9. So 2 times 9 times 2.5. So dl dt is going to equal 18 times 2.5 over 450, which, let's see, 18 times 2 is 36, and another 9 is going to be 45. So I get 45 over 450, which is going to be 1/10. What's the rate of change of the distance? Meters per second, I believe, is the units of our problem. Okay, let's see if I came close. That's not what we want. I want this. Okay, 0.03. I don't even know what my answers were anymore. This question was a lot longer than I thought it would take. Alright, 0.03, done. B is the total distance in meters Ben rides over the 60-second interval from 0 to 60. And then, what's the answer? 139. 139. Alright. Alright, so they found that the slope, the average was slope. The mean value theorem implies that there has to be a v of t that's equal to 2. So pretty straightforward. Last answer is 3/2. Is that what we got? I'm thinking it wasn't. I got 1/10. Alright, let's quickly see what we did wrong. 2L of t, L prime of t. What do we get? 2 L of t times dl dt equals 2bt times db dt. Alright, so we got that part right. And then we just started plugging in and finding answers, and somehow or another I came up with the wrong one. Apparently there's a 2.5 of the 9 right here, and I have 18. And I don't know. I guess I just made a mistake. At 14 minutes on this video, I don't have time to track it down. And there you go. One more to go.